Welcome back to Meet the Pioneers. I'm Deep from NetApp, and I have the privilege to have Yanni again from QCware. And in this episode, we are going to discuss the implications of quantum computing for the financial services industry. Welcome back again, Yanni. Could you take us an overview of what are the use cases for financial services industry?
There are essentially three major classes of use cases. So one that has to do with portfolio optimization. So that could be modeled really as a combinatorial optimization or convex optimization model. Then the second one is encompasses things like anomaly detection or fraud detection or classification in general, right? So actually, in some cases, financial services want to detect maybe certain customers or certain products, certain even trade in some cases, right? So use cases around using machine learning, and then the third, but definitely not, definitely very, very important one has to do with derivative pricing or risk assessments, and it's really based on Monte Carlo simulation.
Cool. Now, AI has been used, we're very much in the financial service industry. So within that machine learning algorithms, are there kind of problems that you could use that will benefit from quantum computers? Are there any particular class of algorithms that can benefit from quantum computers?
Yeah, so you could think of, for example, reinforcement learning being used to identify better trades, to identify timings in the market, to identify things like that, right? So reinforcement learning, more specifically, could be used for certain actions, for essentially best action recommendations. And you could imagine situations where these reinforcement learning models are basically working hand in hand with traders to figure out basically what are essentially the best trades on a certain day in a certain sector, certain financial instruments.
Cool. Now, you talked about portfolio optimization, and there are a broad class of problems that can benefit from optimization algorithms, right? And my first question is that why should you consider quantum computing for optimization algorithms? And the second question is that in the optimization algorithms, there are a broad class of problems, right? So there are convex optimization problems, combinatorial optimization problems. So which of these algorithms could potentially benefit from quantum computers?
Right. So optimization is very tricky. So everything we do today in optimization is actually a heuristic. So we're not guaranteed to get an answer. So all the classical solvers we use today are basically heuristics that sometimes work really well, but other times essentially fail. So the way to think about quantum computing in the context of optimization is that it's going to be yet another tool that optimization experts can use to attack some of these very, very hard problems. So there's actually no guarantee that quantum computers will be able to solve optimization problems faster, but that is really the expectation for most of the experts and most of the analysts. Now, to take it one step further and kind of answer the second part of your question, which had to do with the differentiation between combinatorial optimization and convex optimization, what happens today is that near-term quantum computers, and specifically also quantum annealers, are really good at solving these binary optimization problems, the combinatorial optimization problems. Then the next step would be for those computers to be able to start solving integer problems. And then the last one would be the linear problems, which actually happen to be the easiest for the classical infrastructure. So for quantum computers, kind of this how hard is a problem and how hard is a model is actually almost the reverse of how easy and how hard it is for classical infrastructure.
Cool. I was just reading a report from the World Economic Forum called The Physics of Financial Services. And in that recommendation report, there were three pillars that you have to consider. One is AI cloud, and also to consider quantum computing as your third pillar. Now, the fully fault-tolerant quantum computers are not available today, is it? It's only available maybe a few years down the lane. So I was wondering, why should financial services organization, they should consider quantum computing today?
Yeah, very good question. So the answer really, it's all about essentially insurance, right? It's insuring your future against this potentially very, very disruptive technology and very, very disruptive competitors or new entrants coming into the market and using this new technology that can achieve great results, right? So by doing a project today, by engaging in quantum computing today, these financial services companies are essentially ensuring themselves that they're not going to get blindsided, that someone is not going to essentially come out and they're not going to find in the news that there's this new service or this new technology that someone is already essentially putting into production use. So you can think of it as essentially paying a small premium, engaging in quantum computing today in order to be insured for this future, which yes can be maybe 3 or 5, depending on the use case and depending on exactly what you're doing. It could be several years away.
Yeah. So it's fundamentally a disruptive technology that you can't ignore. So you have to get started anyway. So do it today. Yeah, that's the idea.
Exactly. And actually, what I actually also do is draw a parallel to ML and AI, right? So 5 or 6 or 7 years ago, depending on what time frame you want to pick, we didn't have many of the ML and AI algorithms or systems or models we are very familiar today. Natural language processing, image classification, things like that actually did not exist, right? And so within a very short time frame, 6 or 7 years, we're able now sectors, many different industry sectors we're able to capitalize and use these technologies for disruption, for new offerings, and for critical business processes. And the thinking is that the same will happen with quantum computing. Quantum computing is that next wave. So the sooner you start getting ready, the sooner you build internal skills and processes to take advantage of quantum computing, the better prepared you're going to be for that future.
Yeah, I can totally relate to that because I started using neural networks, say 7 or 8 years ago, and there were no GPUs available at the time, and nobody was advising to use neural networks, use classical machine learning algorithms. And then when GPUs came along, and when you have the accelerated power, then deep learning kind of took off. So I can totally agree with you that it's as the quantum computers become more and more powerful, I think that customers will find more and more interesting applications with them. Now, a lot of financial service organizations spend a lot of money on managing their risks. And also, a lot of this pricing are very, very complex. So do you see any applications, say, for example, on Monte Carlo methods in the quantum computing world for FSI?
Absolutely. That's actually a central use case. Right now, what we hear from large investment banks, for example, is that they can only price certain very complex assets and complex portfolios essentially once overnight. So they use things like GPU farms, and they run the analysis overnight. And so that when the traders come in the morning, they get the numbers from the overnight analysis. But it's something that even on these very large GPU farms can take multiple hours. And if something happens in the market, then the analysts really cannot run another fresh calculation, right? So there's a really big need there to actually be able to execute Monte Carlo analysis much, much faster, to be able to have this intraday essentially response time and refresher of the prices of the things that you're pricing. And quantum computing is promising to deliver that performance advantage.
Cool. And are there any customers that you're planning to work in the future for Monte Carlo simulations or other algorithms?
So actually, we're already working with Goldman Sachs. So it's public, and there's actually several publications in the press and also several papers that we've actually put out together with the Goldman Sachs research team on how we can execute how we can execute Monte Carlo algorithms today, and how we can effectively fit the very large calculation into the existing resources. Now, it's still not ready for production. It's still going to be a few years before it's ready for production, but we're showing basically what's the best that we can do today and how we can bring the time frame forward.
Oh, wow. Yeah, it's fantastic to hear that we were already working with banks to doing quantum computing today. So if I want to learn more about industrial use cases of financial services, so what do I need to do?
Yeah, so one thing you could do is go to a quantum computing conference, and we as QCware actually have several community initiatives to bring together the community and educate the community, educate the different industrial sectors as to what others are doing. So our conference is called Q2B, as in B2B or B2C. And it happens every year in December. Actually, this year we're in our 5th installment. It's going to happen in person in Silicon Valley. So it's actually taking place at the Santa Clara Convention Center, December 7th through the 9th, 2021.
Fantastic. It's always a pleasure to chat with you, Yanni. Every time I talk to you, my eyes are open and I learn something new. So thanks for coming along, and all the details of what we have discussed will be available in my blog. Thanks for watching, and watch out for the next episode where we examine whether quantum computing is useful for the pharmaceutical industry.